This week we're going to continue with insects and mites as well that pull fluid out of the plant, but many of these are going to have a twist. They're going to have some toxic saliva that may cause some disorder in addition to just removing the sap from the plant, or they may be a vector of some kind of plant pathogen. So in this week, we're going to continue a review of the basics of insect groups that feed with sucking mouthparts. But there's going to be an emphasis here on those that have toxic saliva or are important as vectors of certain kinds of plant pathogens. Continue to illustrate diagnostic features that are associated with these injuries that the insects produce and the pathogens that they vector. And finally, to discuss briefly the management principles for these insect pest groups. So, this first module is going to deal with a group of insects called psyllids. They're in this order Hemiptera, as are aphids, and there's actually 3 families now that are considered to be called psyllids. The general appearance of a psyllid, what is a psyllid, aside from being an insect with a kind of weird way of spelling their name? It's an insect that in the adult stage often they look kind of like a cicada. I'm not sure if you've seen a cicada, probably most of you have, but there's a cicada on the right, and there's a couple of psyllids. A psyllid or scilla, you'll see both of those terms used to describe it. But they're only about the size of an aphid, and furthermore, they can jump. The psyllids are sometimes called jumping plant lice, and that's related to the word plant lice being used as to describe aphids in Britain, and these would be presumably aphids that jump. They're again not aphids; they're in a different family or different families, but that's why they're sometimes called jumping plant lice. Immature stages of these will look considerably different. They'll be generally flattened. They'll be on a leaf or sometimes a green stem. The wing pads do become a little more obvious as they get older, but look very different from the adult stage. Some of them will excrete honeydew. Some of them will excrete certain kinds of waxy materials, and these are going to be useful in diagnostics. And in vegetables and fruits, there's 4 main things that could be done by a psyllid. One, they could remove fluid from the phloem, and presumably if enough of that was happening, then that would be adversely affecting the plant. But many of them concurrently introduce saliva that has some sort of toxic effect on the plant. Honeydew may be produced by some, and the 3 examples I'm going to show you here are all vectors of plant pathogens of one crop or another. We'll return to psyllids later if you take the 3rd class on landscape plants, and we'll talk about psyllids making little bumps on leaves or certain kinds of galls. Anyway, but let's deal with the ones here on fruits and vegetables. My favorite, it's a local issue here. One of my favorite insects that works on vegetables is called the potato-tomato psyllid, or tomato-potato psyllid, or potato psyllid, or tomato psyllid. It has two common names that are accepted. And it is primarily important because it introduces saliva that is toxic to the plant and can produce a condition called psyllid yellows, and we'll talk about that. The 2 kinds of crops that are most susceptible to the effects of potato-tomato psyllid are potatoes and tomatoes. Other plants that this insect feeds on, peppers, tomatillo, don't seem to be seriously injured. There is some concern about these damaging peppers in California, but I haven't seen them damage peppers here. They seem to be fairly immune to the effects. So, sorry for this old picture. It predates me, but this is an old picture from showing the distribution of potato-tomato psyllid in general. And what it shows is that this is a migratory insect that in the winter is found in extreme southwestern parts of the United States, Arizona, California, parts of Texas, and of course into Mexico. And in the wintertime, that's where you would find it. But every year, as it gets warm in those southern areas, this insect will migrate northward and settle out to some degree somewhere north. And in the state where I live, it's very commonly an area where they'll settle out. So it's an annual migrant. They can not survive winters in areas with very cold, freezing temperature, and they will then disperse back and again spend wintertime in the south. So it's a migratory insect, and when you have an insect like this, if you live in an area outside of where they overwinter, every year could be different. It's entirely dependent on how many fly up from the south that year. So if it was bad one year, that means nothing in terms of how bad it might be the next year, and vice versa. So the insect is small. We've already talked about this. So this would be an adult psyllid picture on the right, but in the upper left, there's a tiny one I think you can see on that tomato leaf, and again on the lower left, there's a tiny one on tomato fruit. So these are not small insects, but they do have some bands on them. These white bands that are pretty readily seen, even if you don't have magnification. So these would be some adult tomato psyllids, and these are ones that will jump, the jumping plant lice, so they're one of them. They'll lay eggs, and if you read about them, they'll say the eggs are laid on a stalk, and I think you might be able to see in these pictures that there are small eggs, and in this case, most of the ones you can see are along the edges of the leaf. And yes, they're on a stalk, but it's nothing like the stalk that we saw a few weeks ago when we were talking about green lacewings. Their stalk would be many times longer. These are quite small, and often they're in the middle of the leaf, so you wouldn't even notice that there was a little stalk. Anyway, they lay their eggs on the leaves. The eggs hatch, and you have the immature forms. And here's a mixture of stages of immature tomato psyllid. The smaller ones tend to be a little browner. The older ones tend to be a little greener, and obviously they get bigger as they get older. This picture we've got on the right, we've got a late stage psyllid that has good, well-developed wing pads, and left of that is a psyllid that is emerging from a skin, the skin of the previous stage. And if it's an adult that's emerging from that, the adult will initially be green. So in the left part of this picture, under where it says newly emerged adult, you can see the old skin to the left, and then the newly emerged adult that's green. It will take them a few days before they're fully patterned after they've emerged from that last nymphal skin. So here is a couple of stages again: the adult, the old nymphal skin, and a late stage nymph. And one of the things I want you to notice is the late stage nymph here, and there's a little bit of white material coming out the hind end, and there's also another piece of it a little to the left of that. This is the excrement this insect produces. It's called psyllid sugar, and I don't know of another insect that produces this kind of material that's associated with fruits and vegetables around here. It's about the consistency of granulated salt or sugar, and it is a kind of wax-coated sugary pellet. So they don't produce honeydew. It comes out as these little tiny wax pellets, the psyllid sugar, and it will collect around the insect or underneath the insect, and if you don't have a lot of wind, it may become very visible. It's going to be an excellent diagnostic. So here would be quite a bit of it on some tomato leaves that were in a greenhouse and just covered, and then you just look up above where this psyllid sugar has accumulated, and you'll find the insects that are producing it. So this is again an excellent way to detect if it's in a greenhouse. Now the main reason this insect is important is it is capable of producing disorders in susceptible plants through the effects of its saliva. The condition that it produces, first described in the 1920s, is known as psyllid yellows. And this is a plant disease produced from the effects of a toxic saliva. So in this case, the insect's saliva going in is the most important thing that's happening in terms of causing some sort of plant injury. What it takes out of the plant is pretty much irrelevant. It's not very much. It's probably fully compensated by the plant. But what it puts in can have some very bizarre effects. And these kinds of effects are cumulative, called psyllid yellows. So it's a plant disease, but it's caused by an insect toxin The term plant toxemia is sometimes used for these kinds of plant diseases. No pathogen involved. The insect produces the disorder. So part of the reason it's called psyllid yellows is that in certain varieties of potatoes, particularly the russets and the whites, you might see a brilliant color change to a yellow. So very, very light color, very striking sometimes. If you have a red variety or a blue potato, you're getting a little more purpling. But that's why it's called psyllid yellows. So this would be a field that's fairly uniformly infested with potato psyllid and showing psyllid yellows. I'm not sure if you know what potatoes are supposed to look like, but that's not it. The potatoes have a nice dark green color that is not being shown here. This is psyllid yellows. You might get some twisting. There's a couple other things that can cause twisting, but usually the growth stops or the new growth is small. So you might have a compact, smaller plant, a little more tight, a little more rosetted growth. And the big thing is not what happens to the above ground parts, the foliage, the plants, what it does to the part of the crop we're trying to take for yield. So in this picture, we have on the left side, we have a row of potatoes, a couple different varieties as you go down the row. And on the right is a row of potatoes, the same varieties, but the difference between these two rows is the one on the left was controlled for psyllid and the one on the right was not. So you can see that there is differences in size of the plants, a lot of bright yellowing in the side on the right. But the big thing, we're growing potatoes, we're not growing the tops, we're growing the tubers, and the big thing is there are dramatic reductions in yield. So tuber size is greatly affected, and if psyllids come in early, in the season when their plants are just sizing up and you have good numbers, you can have essentially complete crop loss, and that happens periodically in eastern Colorado and has for forever since people have been growing potatoes. So smaller size, reduced yield is one thing you'll see, but then there's other things that can happen. On the top, you might see tubers or at least thickened swellings at the inner nodes in the above ground part, and this is indicating that there's something affecting how nutrients are moving around, sugars are moving around, and it's having some effect on the growth of the plant to see this top growth effect. But then getting back underneath the plant on the tubers, it can affect dormancy. So tubers remain dormant for a certain amount of time, usually many months, and then ultimately they start to sprout. Well, one of the things you might see if your crop had been affected by potato-tomato psyllid is that the tubers might sprout and then have another little tuber associated with them. And maybe that would sprout and you get another one. These are called chain tubers, and this is obviously a market defect. Another thing would be just prematurely sprouting, even if you did not have the chain tubers being formed. So in this case, in the upper left, was a potato I dug that had already sprouted before harvest, and the ones on the right, they sprouted about 2 weeks after they had been dug, and this is very prematurely. So very premature for them to sprout. Normally, there are dormancy factors in the tubers that will prevent them from sprouting for many months, but it's shot if the top of the plant has been infested by potato psyllid, and it does not take many. It could be a dozen. The toxin translocating in some way to affect tuber dormancy below ground. Pretty amazing thing for an insect to do. Tomato, it's a little more subtle. You'll get new growth comes out small, you'll get some purpling, so it's not nearly as dramatic. You don't have the bright yellow change of color, and the effects on the yield are a little more subtle. So you'd have smaller tomatoes often. They might be duller in color, but they will also not have the right sugars, so it'll have a taste that is not as enjoyable, so it'll be a little more disappointing. But there are fairly dramatic things that can happen to tomatoes too in terms of tomato quality. This is an insect that comes very irregularly. It's not predictable. Again, it's a migratory insect. When you have one of those, in order for you to keep on top of it, you will have to sample every single year. Again, it does not matter what happened in the last year. This year could be a big year or could be a small year, and the only way you'll know is to sample. So I find if you can get a sweep net, that will be the best way for you to get heads up if potato-tomato psyllid is in your area. And a sweep net would be swept through the crop you have that would be susceptible. In this case, potatoes. It could be tomatoes. It could be peppers. And look for those adults. The adults, they're crowded in that picture in the lower right. It's a little tough to see. Small, they're about the size of a flea beetle, and they jump like a flea beetle. But if you can get the color difference, the banding, and look closely, you should be able to figure this out. Leaf sampling, you can check for check leaves, and this is something that would be done if you wanted to see if certain things were controlling it. But just a heads up, the psyllid is an insect that's extremely clumped in their distribution on plants, meaning there may be a leaf that has a lot of them and then 49 other leaves that have none. So you have to sample a lot of leaves to get a reasonable estimate of whether the insect is present and how common through leaf sampling. Middle part of the plant's often the best site. They don't like it up high. They don't like if it's brightly lit. But anyway, that's one way to sample. And if you want to know if they have settled in the area, I find peppers to be the easiest crop to find psyllid nymphs on. The leaves are a little more glossy. It's easy to see. And they like peppers. They just don't damage peppers like they do the other crops. And if it's in a greenhouse, remember the psyllid sugar. There's no other insect I think I can think of that would be more easily recognizable solely on the kind of material it excretes. You see that kind of product in a hoop house or a greenhouse tomato production facility, you know you've got psyllids. You just got to look up and find those. So again, that's psyllid sugar. One more recent thing that's associated with the potato psyllid is that it has been found to transmit a pathogen that's a kind of bacterium known as a phytoplasma. And the disease that it can transmit produces a condition called zebra chip. So in this case, the condition is a problem on potatoes. The insect vector is this tomato-potato psyllid. The causal organism is something called Candidatus liberibacter solanacearum. But the way it gets into a plant is a psyllid. This psyllid feeds on an infected plant, moves to a healthy plant, and introduces the pathogen into that. So the foliar symptoms you'll see with zebra chip overlap quite a bit with what psyllid produces in just psyllid yellows. So that would be hard to tell if just looking at the foliage what you had. Did you have zebra chip? But the issue with it shows up when you harvest the tubers. And with zebra chip, you'll get some discoloration of the tuber, but where it really shows up if you try to fry it, making chips. And you'll get darkened chips or chips with dark areas. And that's because zebra chip affects the distribution and production of sugars in the tuber, and sugars have a lot to do with chip color. Anyway, this has been a big problem in northern Mexico for maybe 20 years. Southern Texas is a pretty big deal. Southern California can be. It's crept into the big production areas in the Northwest a little bit. Here in Colorado, we see it a few infected psyllids every once in a while, but essentially it's fairly irrelevant in this state. We've got just straight old psyllid yellows, which again by itself can be a pretty big problem. So two other psyllids I want to talk about much less detail. Both of them are trees, and one would be the pear psylla, and this is associated with common pear. The pear psylla is an insect that you'll find moving to the plants in spring. And in this picture, I think you can see the adult. And then those tiny little yellow objects that I've got an arrow next to, those are the eggs that it lays. So the adults are out there just before bud break, and this is a key time for trying to see if they are present. And in orchards where pear psylla is a problem, this is a scouting method that is done to check at this time of year. And often they will then intercede with dormant oils to kill those eggs. Treating psyllid in orchards early in the year is critical for control of this species. Pear psylla, you treat early, and that can usually get you through the year. Some other symptoms you might see is where they feed, you might get a small necrotic spot on the leaf. They also produce a lot of honeydew, and the honeydew lenses a little bit and may also cause some damage to the tissues underneath it. By lensing, I mean sunlight goes through and it burns the foliage. So you might get little dark spots around where psyllids feed, either through the effects of the insect feeding, but also from the honeydew just staying there on that plant. And they do produce a lot of honeydew, and it's quite viscous. It's stickier, gooier than the kind you might get from an aphid. And if you have high numbers of psyllids, then the honeydew may then drip on the fruit. So then you get honeydew on the pear fruit, and then you may have sooty mold growing on the pear fruit, growing on the honeydew. It also can do a couple of things to the plant in addition to just the removal of the fluids and the production of honeydew. If you have very high numbers of psyllids, there is a condition known as psylla shock that can occur, and this often causes the plant to lose leaves. So this would be a plant response to the effect of a large amount of saliva being introduced by this insect. This insect does have a saliva that is toxic to its host plant. It's not nearly as toxic to pears as tomato potato psyllid is to potato, but it does have saliva that is slightly toxic in high numbers, will cause leaf drop, premature leaf drop. So that's psylla shock, and then that may have some carryover effects the next year, but then the plant outgrows it. The other thing is that it can vector a pathogen. In this case, it's another phytoplasma, again a kind of bacterium, but it's the phytoplasma that produces pear decline. And it's another Candidatus species of phytoplasm name, Phytoplasma pyri. And pear decline can show different effects. In some pears, you can have acute decline. You can have tree death fairly rapidly. And this occurs on pears that have susceptible rootstocks to this organism. More often, it's more of a general decline or a periodic decline, so they decline and then they regrow the next year and then decline a little. So you get a thinner crown, more spindly crown. You might see early change, prematurely early change in foliage color on an affected plant. So those are symptoms of a pathogen. You can't completely clear a tree of the pathogen once it's got it, but in this case it does retreat. In the wintertime, the organism that causes this is eliminated from the very ends of the trees, the branches, but it then recolonizes every year. So pear decline can be a moderately important disease condition of the pears, and it occurs throughout North America. Now the big new issue with a psyllid involved in transmitting a pathogen involves the Asian citrus psyllid and a disease of citrus called Huang Longbing or citrus greening disease. So this is caused by an introduced psyllid, the Asian citrus psyllid, introduced into North America, and it is a little bit different in appearance than the ones I showed you before. The adults stick their back end up in a very fairly unique way. It makes them look like little thorns. and they will produce a small amount of wax. So I think you can see the small amount of wax that's on the leaf illustrated in this picture. But it's nothing you would generally notice. It doesn't produce the big wax pellets that you would see produced by the potato-tomato psyllid. And usually outdoors on a citrus tree, it of course would all blow away. Eggs are laid on the plant. You have 5 nymphal instars. I showed this picture earlier, and these are going to be feeding on the leaves, on the stems of the citrus plant. And by itself, this insect is not really very important. It's taking out a little bit of fluid like some aphids do. And it doesn't introduce a toxic saliva like the previous 2 psyllids do. But the big thing is it is a vector that can carry the pathogen that causes this terrible disease, Huang Longbing or citrus greening disease. And a citrus tree, once infected, will go into a decline condition and usually ultimately death. And this is having devastating effects in areas where this disease gets established. Right now, we're talking Florida. The Florida citrus industry has never met a bigger threat than this disease going on right now. This could take out the citrus industry in Florida. But you see these conditions, these decline, ultimate death of the tree. There's also problems on trees that reduce fruit quality. The infection causes seed abortion or seeds to form incompletely. You get the fruit also becoming distorted, in part related to that. The fruit won't green up, or won't ripen up. It will stay green, so you get this irregular ripening. And again, this can have devastating effects on the crop. Fairly new condition, citrus greening and the Asian citrus psyllid again are well established and doing enormous damage in Florida now, but they have been found in other citrus producing areas in the country. In an area of Texas, it's also been found. Both of them have been found in California. At present, just in LA County, and several hundred miles from the citrus producing areas, but it has gotten around the country. And what is the future of citrus production where citrus greening disease becomes established? That's a $1 million question or $1 billion question. People are really struggling trying to figure out a way that they can manage this. And frankly, the most common thing I'm hearing right now is developing genetically modified citrus that is capable of resisting this disease organism, because otherwise the alternatives aren't working. Insecticides can't control this. Anyway, who knows? But you might want to read up a little more on citrus greening. Okay, that's it for the psyllids, and we're going to talk about another group in the next module here.